So the reason we embarked into developing Exocet FlyingShape is that so far there was no solution to properly measure the cells and to properly understand what happens in their shapes and in their setups. And so, like with the development of LiDARs in the industry and the automotive industry, it was becoming an obvious solution to actually measure these cells and help the sailors and help the cell designers to improve their adjustments and designs.
So we try to solve a problem. The engine of a sailing boat is a sail. Everything outside is drag. We try to, in the performance, to limit the drag, but optimize the engine. And we had no metrics, nothing to base our analysis, our development. So having this data, it makes totally sense, and we try to solve a problem to base our development, how we tune the sail on data, even if perception arrive at the same time. Sail shape measurement is a key factor for the performance. Imagine not having all the data of an engine when you race with a car. It's impossible. Everything outside sail is drag. So having this data, this metric, help us to improve the engine of the boat, help us to tune the sail in a better way when you are sailing, but analyze that after. So it's really a key factor to improve every day and day after day how we sail.
Until a solution like Exocet FlyingShape, people were looking at sails, wondering whether they were properly adjusted or not, whether they were adjusted as they were yesterday, when we were going good or when we were going bad. And people were like discussing and sharing their perception, their eye perception. Now they can actually use actual metrics of camber, twist, and triangle, and so on, like the classical metrics that are used by sail designers to not only adjust the sails, but also exchange about how they are adjusted, how they were adjusted, and whether that's the good setup, and that will ease the communication between the sail trimmers themselves and between the sail trimmers and the sail designers.
We want Exocet FlyingShape to be part of the whole system, electronic system of a racing boat or boat which want to optimize its performance. Technology is aligned today. We have LiDAR developed in all the industry. LiDAR are becoming smaller and smaller, which makes the things possible today to measure in real time and having all the data, the shape of the sail. So yes, we want this system to be plug and play, easy to use for the user, and without any maintenance. No need of engineer behind our system. It is like that the system will help a lot of sailors to best tune their boat. This technology is designed first for the sailor on board, the trimmer, to help them to tune the sail in a better way with data and reference on board. It's also made for designer to get the proper shape of the sail when in real sailing mode. Then they can compare the things with what they designed. So yes, both sailor, designer, and having something to speak with data, which is not only perception, which is metrics, data, analyze. So yes, for all these kind of people. We work also with larger market in the marine industry, like shipping, wind-assisted vessel, where it's a bit dark how to tune the sail. And based on that, we can develop some automation of the sail.
Exocet FlyingShape is made of sensors that we call LiDARs, and some computation force, like a computer. So we install from between 1 and 6 LiDARs on the boat, and the LiDAR will send light beams or in its surroundings, and the light beams will be sent back or reflected back to the LiDAR, and the time for the light to travel is recorded, and from that time we can actually measure the position of the point in space. So we do that, the LiDAR does that hundreds of thousands of times per second, and on a wide range of angle, both vertically and horizontally. So thanks to all these points that are measured in space, we actually get the full shape. There's actually a processing of these points that we then do in the computing unit, the Exocet FlyingShape. And this processing that we do is actually transform these points into what actually is a sail shape, like making sense of it, reconstruct the sail shape, extract the stripes, like the horizontal stripes, and then extract metrics of these stripes.
To integrate the system on board, we must study the best position for sensors based on the current deck layout. So we study the best position, whether it be for the mainsail or the headsail, and then we provide insight as to where it's best to position the sensors.
The metrics that are produced by Exocet FlyingShape are like the classical metrics of sail design, typically draft, camber, twist at various altitude, entry angle, aft angle, like the classical metrics that people in the industry, in the sailing industry, are used to use.
Having all these metrics of the sail when you are sailing helps the trimmer, but also help to build some reference value of how to use the sail in the different conditions, upwind, downwind, high wind, medium wind, and then will make the things easier day after day with reference of how you sail the boat the best, and how so you can match the current shape of your sail with all your reference values. So building all this data makes sense to optimize the performance.
So LiDAR sensors are capable of scanning their environment 20 times every second, and so this generates thousands of data points which are then analyzed through the Exocet FlyingShape dedicated computer. By doing this analysis, we can then rebuild shapes for those sails, and so this is yet again done multiple times every second. And those shapes are then analyzed and transformed into meaningful metrics on board the yachts. Twist and camber values are an example of this. And this data is then sent live into the onboard navigation system, such that sailors, performers, engineers can access this data live and see the consequence of how they are trimming the sails. Once you arrive on shore, you have direct access to the phases which were triggered on water, and in this way you can process the actual shape surfaces of the sails and compare them either in time to one another, but also compare them to theoretical shapes. So the data collected on board during the sailing session is actually very valuable, whether it be for sailors, for performers, for engineers in the sailing teams, but also for sail designers who can then correlate the logs of data of a day's sailing session to theoretical data that they would expect to obtain on these sails. Once we have the raw point cloud, we rebuild the surface of the sail, rebuild its luff, its leech, and any number of stripes we want on the sail. And then using those rebuilt shapes, we then output twist values, camber values, and so on. The process data from the Exocet FlyingShape then arrives into the navigation unit in the Exocet Blue ecosystem, where you can create any number of dashboards which can then be visualized on computers, tablets, smartphones. On these dashboards, you can display the LiDAR data, twist, camber, draft position, and based on the needs of every user, whether they be sailors, performers or engineers, those dashboards can be remodeled to fit all the needs. So the LiDAR data is then entirely redirected through to the web-based Exocet cloud system, where each user can log in and access his data. So the process data from the Exocet FlyingShape then arrives into the Exocet cloud system and is correlated with all the other data from the other sensors on board. Here, for example, several sections, data from the LiDARs, from the navigation system, and the loads are all visualized together. We can display the sailing day data and correlate wind sensors, load sensors with the LiDAR data, twist, camber, and any other metric we want to visualize on the dashboard. On the dashboards, we can also visualize the load and correlate the load data with the LiDAR data.
Professional sailors are used to use targets to adjust their boat. And like the heel is a typical. And now with flying boats, the pitch will be a target. The fly altitude will be a target. And so far we were unable to actually produce and use proper target for sail shapes because there was no metrics produced for them. There was no measures. Now with Exocet FlyingShape, we can actually produce these metrics, and the sailors can now build their targets and replicate their sail shapes to their targets, also for their sails.
Exocet FlyingShape is really a game changer for the trimmer, for the designer. Having this data in live and afterward, when you come back on shore, will help a lot to develop all the engine of your boat. The trimmer, how to use them on board, but the designer, how they develop the tool, their tools, the design tool. Does it match what you really have on when you sail? So yes, a really game changer for this kind of people. Exocet FlyingShape has been developed and tested on different platforms: racing platform, cruising platform, shipping platform. So today, Exocet FlyingShape is ready to be embarked and to be used by the sailor, by the designer, by some automation. And yes, definitely it will help the sailor to tune in a better way, help the designer to improve their design for the next step, help the ship with the sail to better tune automatically the sail. So definitely a game changer for this industry. As part of all the sensors on board, the LiDAR will stay on board and be the solution of sensor that help you to sail your boat the best way. It's another metrics, but a key metrics for your boat, because we speak about the engine of your boat. And yes, this solution will be embedded, easy to use for any sailor. So in this program, MDS bring all its deep expertise in design and simulation, and with lots of experience on the America's Cup, and knowing what LiDAR can improve a sail program. So on Pixel Firmware, we used to develop and to install full equipment, full solution from the sensor to the user. So it was obvious to collaborate together. This product is made for sailor, but also for designer. So having a mix of people on board and designer was also obvious for the design of this solution for all the work we are doing together.
So Exocet FlyingShape just works, and next is to convince people that it does.
With Exocet FlyingShape, you get to know your sail, you make the difference, you improve your performance.